Hello everyone. Today we are going to see one question of geometric progression. In this question we need to prove that s upon r bracket raised to n is equals to p square. Now what is meant by s? S is given sum of all the terms of geometric progression, that is the given sequences in GP. So we need to take s as t1 plus t2 till tn. What is given r? R is sum of all the reciprocals of all the terms of a geometric progression. Now, what's given r? R is 1 upon t1 plus 1 upon t2 till 1 upon tn. Now, what is given p? P is a product of all the terms of the given sequence. That is, capital P is equals to t1 into t2 till we need to take till tn. Now dear children, this condition is given and we have to prove this. Means s upon r bracket raised to n means we have to consider the ratio of s and r and its nth power we need to prove equals to product of all terms of the sequence and bracket raised to 2. Now students, we have, if the given sequence is a GP, then we have one condition that Tn plus 1 upon Tn is equals to R, that is the constant. If we are getting for the given sequence Tn plus 1 upon Tn, if we are getting the constant term, then we have the given sequence is in GP. Now dear children, if we have the sum capital S is equals to T1, T2 until addition till Tn, means we have to take the first constant term and the common ratio R and we have to write the given sequence. That means we have the sequence AR square till AR raised to n minus 1. This is the nth term of the given GP. Now dear children, we have S is equals to the formula of Sn we will write here, that is A into r raised to n minus 1 upon r minus 1. Here we can write the formula as a into 1 minus r raised to n upon 1 minus r. Okay, so what happened here, if we take minus 1 common, we can write the formula in this form. Now here the condition, when your r is strictly less than 1, then we have to write this formula. When your r is greater than 1, then we have to use this formula. Now dear children, here we are going to use the formula r raised to n minus 1 upon r minus 1 into a. Now this formula of Sn we have. Now P, what is P? It's a product of all the terms. So we have a into ar square till we need to take r raised to n minus 1. Now dear children, we have multiplication of a n times, so we can write this as a to the power n. Now if we collect all the terms here, then r into r square into r cube till we have to take r raised to n minus 1. If we see that all the powers are natural numbers and that all numbers are in the sequence. So what we have, a to the power n, and we have to use one formula here. If a raised to m into a raised to n is given, then we have a raised to m plus n. Okay, now so we have r to the power 1 plus 2 plus 3 till which term is there? Last one, that is the n minus 1 plus n minus 1. Okay, no need to give you a bracket. So we have r to the power 1 plus 2 plus 3 till n minus 1. Okay, now we have sum of all natural numbers. If the numbers are in the given sequence, then we have 1 plus 2 plus 3 till n. Then we have the formula that n into n plus 1 upon 2. Okay, so same formula we are going to use here. That is, here our terms are till n minus 1. Then we have the formula a to the power n into r raised to n minus 1, that is n, we are writing n into n plus 1, and the next term, that is n minus 1 plus 1, it gives you n upon 2. Okay, so how we will write it? N minus 1 into n upon 2. Okay, so what we got? This we got P, capital P. Now we have capital P as a to the power n into r to the power n minus 1 into n upon 2, and capital S, this capital S, we have a into r raised to n minus 1 upon r minus 1. Now we have to find capital R. Understood? Now dear students, what is capital R? Now here this S we will write this side. What is S? We have a into r raised to n minus 1 upon r minus 1. And what we have? What we have? This capital P is, here we will write capital P. Capital P, we have a to the power n into r to the power n minus 1 into n upon 2. So we have this P value also. Now we have to use the values in this LHS and RHS. Now we need to find capital R. What is capital R? Capital R is sum of all the reciprocals of the given GP. That is 1 upon A plus 1 upon AR plus 1 upon AR square till it will go 1 upon 8 into R raised to n minus 1. Now students, here, if we see properly, then the first term, that is T1, we are getting 1 upon it, and we are multiplying this T1 by 1 upon R. So what is the common ratio? Suppose R dash we will take, common ratio will be 1 upon R. So what is Sn then? Sn means for this geometric progression, we have this R is equals to first term. What is the formula here? We can see the formula, first term into common ratio is to n minus 1 upon r minus 1. But here 1 upon r is strictly less than 1. So we are going to use the formula, first term 1 upon a into 1 minus 1 upon r to the power n bracket closed upon 1 minus 1 upon r. If we are going to simplify this formula, so what we have 1 upon a, here 1 upon r to the power n, it gives you 1 upon r raised to n, 1 minus 1 upon r raised to n, both thing divided by r minus 1 upon r minus 1 upon r. Are you getting, children? Now what we have, if we simplify it, this r will go up, so it will be r upon a into r minus 1. Okay, and this will be the LCM. So here it will be r raised to n minus 1 upon r raised to n. Understood? Now here we can take this r here, and we are getting r raised to n minus 1. Okay, so what will be the capital R? Capital R will be r upon, we will take r downside, 1 upon a into r raised to n minus 1 upon r minus 1 into 1 upon r raised to n minus 1. Okay, now we have to consider the LHS. Now we will write this r also this side. So what we are getting? R is 1 upon a into r raised to n minus 1 upon r minus 1 into 1 upon r raised to n minus 1. Now we have all these three terms. Now it's very easy, dear children, to prove or to verify LHS equals to RHS. The question is to verify, means it's not given equal. So now we have to consider here LHS part. So what is LHS? What is LHS? LHS is given s upon r to the power n. So your LHS is given s upon r bracket raised to n. What is s? Please put the values. A into r raised to n minus 1 upon r minus 1. And what is r? R is 1 upon a into r raised to n minus 1 upon r minus 1 into 1 upon r raised to n minus 1. Dear children, if we see properly, this bracket and this bracket are exactly equal. That's why we can cancel this. So here a is given. Now students, what is remaining? A upon 1 upon a into 1 upon r raised to n minus 1. As we know that denominator will go in the numerator. So what we are getting? It's equal to it will be a square into r raised to n minus 1. What we are getting? R raised to n minus 1. Okay. So what we have? A square into r raised to n minus 1. But here we have taken s upon r. So its bracket raised to n we need to take. So its bracket raised to n. Then its bracket raised to n. Here also we need to take bracket raised to n. So what we are getting? A raised to 2n and power's power it will coming in the multiplication. So a raised to 2 into n it will be twice n, then r to the power n minus 1 into n. So what it is? It's our LHS. Okay, and now we are going to simplify RHS as well. What is RHS? RHS. It's given p square. P square. What is p, children? Here we can see the value of p, that is a to the power n into r raised to n minus 1 into n upon 2. So its bracket square we need to take. Now here also we can use the law of exponents, and we have a to the power n into r to the power n minus 1 into n upon 2 we are taking, and its square. So a raised to n raised to 2, it gives you simply a to the power 2n and r to the power n minus 1 into n upon 2 and into 2. So what it will be? It will get cancelled. So what we are getting? R to the power n minus 1 into n, and this exactly equal with your LHS. So it's very simple that when the sum of all the terms of a GP, when sum of all the reciprocals of the GP, reciprocals of all terms of a GP, its raised to n power, means its nth power is given, we can prove it equal to product of all terms and bracket product of all terms of the GP power 2. So dear children, here we have proved this properly. Thank you.